Sorry everyone, I had some technical error. I just moved out from the meet. So shall we start? Hope everyone has joined. So am I audible to everyone?
Yes, ma'am, you are audible.
Yeah. So this. So we'll start the experiment. So please tell me what all you have doubts. What all doubts you have. Tell me.
Ma'am, in this Zener diode experiment,
Yeah,
week 7,
week
uh,
7. Yes.
yeah. So if breakdown voltage of Zener diode is 3.6,
Yes.
despite that, I don't get to see the output voltage as 3.6, irrespective of whether it is no load or with some load. It comes around 2.8 something.
But see, Zener diode it should show 3.6. As it is mentioned already in the PDF, see, it should be there will be some changes of 0.2 volt maximum. Correct?
But
So what all connection you have done?
I
What
mean,
connection?
I'm providing just plain DC signal as an input, 4.3 volt DC,
Okay.
and 500 ohms is the RS, is the value of RS, which is in
Uh,
series.
so 500. See in part 1, point number 4. Set the series resistance RS to 250 ohms. So
Yes,
RS, have you tried with 250 ohms?
yes, ma'am. I tried that.
So 250 ohms and RL should be from 10 kilo ohm to 100 ohms, right?
Yes, ma'am.
So basically, uh, the way of doing is you will find the VTH, V Thevenin, Thevenin equivalent of the equivalent voltage, right, of the circuit, right, across that Zener diode. Okay. Have you calculated VTH?
No, ma'am. I didn't thought of applying Thevenin voltage. I
So it's using actually what is the why you should calculate because you will get to know what will be the voltage across the if in play if you open circuit the Zener diode, what should be voltage across the Zener diode because of the Vs. Okay, got
So
my
that
point,
means
right?
if I remove Zener diode in that
Huh.
scenario, what will be the
Some
voltage across?
voltage across the RL, right?
So that will be a simple voltage divider, right?
Yeah, correct. Simple voltage divided RL by RS plus RL
Yeah,
into
yes, ma'am.
what is the voltage you are giving, right? So
4.3
maybe
volts. Yeah,
4.3 volts. So 250 by no, sorry, maybe if you give 1K, let's
yeah,
say
yeah.
1K, how much it should come?
So 1/4, it will be around 1.1 volt, around 1.1 volt.
Should be,
Sorry, it is.
sorry,
It will be
1000 divided by 1
1,250.
1250, right?
Yeah. So
Into
455.
4.3, correct?
Yeah. Yes, ma'am.
So this is 3.44, correct?
Yeah.
So which is less than the breakdown voltage, right?
Yes.
So you will not get anything. So the Zener diode didn't reach the breakdown voltage only. Understood my point?
I got you. Yeah.
Yeah? So you need to provide a voltage that should be more than the more equal or more than the 3.6 Zener breakdown voltage, correct? Then only there will be breakdown. No? Then only there will be current flow.
I got your point, ma'am.
Yeah.
Um,
So I think maybe you what you can do is try some higher that RL value. basically what VTH will change depending on three things, three variables. That is, if you change the source voltage, if you change the series resistance, that is 250 or RS or 500 ohms, whatever you want to, or if you change the RL, correct?
So,
So if any of these variables change, then the VTH will change. No, are you able to follow? Hello?
once, yeah, I got your point, ma'am.
Yeah. So you have to, that's why it is told that vary the load resistance from 10 kilo ohms to 100 kilo ohms, 100 ohms, and record the range of RL for which the regulator provides a regulated output voltage of 3.6 plus or minus 0.2 volt. So maybe your RL is not correct value, not in the range that gives the VTH greater than the Zener breakdown voltage.
But this actually, I observed it both in simulation as well as in actual circuit as well.
Okay, what did you, so RL, what value have you given?
I I tried different values starting from no load till 10K.
10K. So if I provide
In
10K,
steps of 1K, I incremented RL in steps of 1K.
so maybe let's say we'll try with 5K, correct?
Yeah,
5K, what should be the value? 5,000 divided by
divided by 500.
5250, correct?
Yeah,
Into 4 point, how much value is it? 4.09. So if your Zener breakdown voltage is 3.6, it should come around, it should give some value theoretically.
yeah. Theoretically, it should limit my output to 3.6.
3.6, correct. But you have not gotten this thing. You
I
are
mean,
how much
uh,
value you are getting.
it it never touches 3.6. It
But
always remains below 3.5 or so.
what is the maximum value that you are getting that from your
3.5.
3.5?
3.5. Yeah.
Yeah, then it is fine. See, it is giving 3.6 because we are saying 3.6 because that is a maybe Zener diode that we have provided with this like, what should I say? This 3.6 voltage breakdown voltage, Zener breakdown voltage. So we are expecting that if 3.5 also you're getting, it's fine. But it should be constant value for a range of RL. That is one thing you have to observe.
For the range of RL, I mean, from for across this entire range, it should remain
No, no,
3.5.
no, not, no, no, no. See, what I showed you, right? For 1K, it is coming below 3.6. VTH is coming below 3.6, no?
Yes, ma'am.
So it will not uh, show any current. Very less current will flow through that, right?
Ma'am, allow me to share one graph with you. Maybe if I can share.
Yeah, yeah, sure.
Yeah, because this graph was generated through LTspice as
Hmm.
was instructed in the notes.
Okay.
So can I share on here?
There is one thing called share screen.
Whiteboard.
So,
Sorry, I can't locate share screen.
see, there are mute, start video,
Yeah,
participants, and then there, chat, and then
that
share screen.
okay. I got it. Share
Yeah.
screen. So I'm sharing my screen right
Okay,
now.
okay, okay.
So this is the graph that I observed uh, on LTspice. Can you see the screen? Can
Yeah,
you?
yeah, yeah, yeah. Yes.
Yeah. So the input is ranging between 3.8 and 4.8. It's a triangular waveform.
I think you are going wrong. So 3.8 and uh, okay, just a minute. I'll just check. So 4.3 peak voltage is the triangular value is 0.5, correct? So 4.3, yeah, correct. Yeah. Yes,
Yeah, so the curve in blue is the input
input, yeah.
triangular waveform,
Hmm.
and the curves that you get to see below the green curves are curves at different values of RL. So
Okay,
the the one which is most triangular, looks like almost like a triangular, is
this one, the
is
lower one.
the lower one is with the least value of RL, which is in my case it was 1K, and then the topmost one is with 10K. So you see it is actually not touching 3.6 anywhere. And this is just
Okay,
with
so
simulation.
what Zener diode have you used? Zener diode, did you check the breakdown voltage of the Zener diode that you have been using?
3.6 only, ma'am.
Are you sure in the LTspice 3.6 only?
It's not available out of the box like in the components library, but
Hmm.
you can create a copy of the existing Zener components and then change the values to,
Change the values to just pick a diode kind of
yeah.
like
So
that
the
you
one,
have done,
yeah,
where
so
it is written that that it is the breakdown voltage different values of breakdown voltages are given for Zener diode, Schottky diode, like
yeah,
that.
ma'am. Yeah. So in
Okay.
case you want, I can open up and show that to you.
Yeah, that will be good. How I wanted to see.
1 second, ma'am.
Yeah, sure.
So yeah, so this is what my schematic looks like.
Mm-hmm.
Uh, this is a Zener diode, and if I right click it, so
Because
from
yes, breakdown voltage is 3.6, correct.
this is what I changed, the value that I changed. I copied this 1 and 750 and then change its parameters to 3.6
Okay.
for the purpose of simulation.
Okay.
And
So you can change it here in the breakdown that the table can open again, box can open.
yeah, 1 second.
So you have
Here,
changed here. You have just changed the value, right?
no, this is not where I changed. I means this is not editable over
Okay.
here.
Yeah. That's what I was thinking.
So this
So
is means I had to make this change, like opening up some other file in the components CMP lab. I forgot what was
okay.
the name. Yeah, this is the standard library, I believe.
Okay.
So if I open this, and yeah, so this
Yeah.
is the list
Others
of
can also
all the,
just a minute, Gaurav. Others can also follow through what is he has done to change the value of this breakdown voltage. You can also make a note of it. Yeah. Continue.
so I opened up that file. So that file
Hmm.
is available in the local data folder for this installation of LTspice on my
Okay.
system.
Okay.
So, and this I referred to some documents online. That's
Okay.
how I got to know about this.
Mm-hmm.
So, um, this file contains the specification for all the diodes which
Okay.
LTspice can uh, use.
Hmm.
And here, this is 1N750, which I found having a breakdown voltage of 4.7.
4.7. Correct. Yeah.
I copied this entire row and created a new row just below it, which is
Hmm.
this one.
Okay.
And I I changed breakdown voltage to 3.6, and one more value I had to change, which was this
This
VP.
one also. VP, I think. No? VP,
So,
VP knee voltage. Acha. I think that is a knee voltage. I think so. Yeah. Okay. These two have changed. Okay. Understood. Hmm.
so uh, the graph that I showed, that was generated for this um, schematic,
Okay.
uh, providing a triangular waveform ranging between 3.8 to 4.8.
And
So
what is this RI?
this is the potentiometer. RI is the third terminal of potentiometer, which is connect means
Okay.
I'm just keeping it open, but the RL value will be varying.
Varying. Okay. 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 Correct. Correct.
So it
Yes.
will vary from 1K to 10K in steps
Mm-hmm.
of 10K. So if I run this, uh, yeah, so this is the voltage at the output. Sorry, I'll pick up the input voltage as well, but that will remove the color coding for these different values. So these are the legends you see.
Yeah.
So
One.
the lowest curve is for 9K.
First one is for okay. Hmm. So if you increase the
So as I'm increasing the value of my mm, R in, which is the uh, the resistance which is not connected, the top
okay,
one.
the other one. So this one will decrease, right?
Yeah,
Understood.
so RL, yeah, so RL
RL will
will be
decrease.
10K minus this value. So the lowest curve belongs to 1K
1K.
RL.
Mm-hmm. And then
So
along 2K like that.
yeah, yeah.
Okay.
So
But
my
it should
question was, it it never touches 3.6.
3.6.
Yeah, and for values like 1K, it is almost triangular. And if I do it like on a breadboard,
Huh.
uh, actually,
What did
so
you get there?
the values not do not change at means there is a change at the lower levels of RL like 1K, 2K, and 3K.
Hmm.
Till 5K, I see some variation, but above 5K, the values are almost means not almost are the same for means a
Around from 1K to 5K, correct? For RL value.
from for RL values of 6K to 10K.
Hmm.
The minimum and maximum values for the output voltage for me, it ranges between 3.3 to 3.7 volt for 220 ohms RS.
250 ohms. Okay.
220 ohms RS. I didn't have 250.
Sure. So you have done 220. Okay.
I didn't have 250 exactly with me.
Mm-hmm.
I used 220.
So 220. So how much it should come?
So 220 and the I'm varying load from 1K to 10K.
Hmm.
So
1K to 5K, how much is it coming?
there means for 1K, it ranges between 2.95. That's a minimum value, and the maximum is 3.5.
Maximum 3.5. There also 2.9 and 3.5. There, the variation is like that.
Yeah, it's a
And
like
1 to 5K and 6K to 9K.
for
It
five
is
for 5K it is 3.25 to 3.7. So from 1K to 5K, there's a gradual increase
in the breakdown voltage, right?
in the like the peak,
That
peak to peak
yeah,
of the output.
correct.
But after 5K, like from 6K onwards, it
Hmm.
is like 3.3 and 3.7.
So that means almost 0.3 variations there, right? And
Yeah,
down it is
0.35,
0.33
0.35 volt of variation.
variation. So practical diodes, it can happen like that. Yeah. So I'm still not sure why you are keep getting like that. Theoretically, it should not be the case. Maybe I'll confirm it with professor, and maybe I'll get back to you. That is fine.
Yeah, and one
Yeah.
last question I
Yeah.
had is regarding the last part of this experiment, which
Hmm.
was we need to keep the uh, RL and RS constant and uh, vary the peak to peak of the input voltage. Like DC value should remain 4.3, but we
Which
should
one?
have,
Which one? Which one? Last part.
yeah, I think it is point 0.8 or I'll have to open them.
From the circuit with one Zener diode, RS should be 500 ohms and RL should be 1 kilo ohm. This one?
I'll open up the draft now.
Yeah.
Yeah, point 10.
Point 10. What did it say that from the circuit with one Zener? RS 500 ohms and RL 1 kilo ohm, vary VS2. Vary VS2. Okay. Acha, one more thing. Can you show me this diagram, please? That LTspice diagram, please.
For point 10,
No, no, no. Previous schematic. Schematic, you can show me.
yeah, so schematic is different for point 10, where there we do
4.8,
point potential.
4.10. See, you should use two voltage source. No, one will be that is 4 point. No, it is going correctly. There you have. Now, what they have said actually, basically, I think you have to use two voltage source here. You have used one, no?
Yeah,
So you have given upper one as 3.8 and the lower one as 3.8 and upper this is 4.8. Correct? Like that.
this
That
is
you have given.
actually a combination of that only, right?
Yeah,
Isn't it?
yeah. That is true. I agree. Now in the next, that's what I'm coming to that. So vary VS2.
Yeah,
So if you have taken two voltages, okay, one
yeah,
is only in the schematic. If you have taken only one DC voltage, that will give 4.3,
4.3
and
constant.
another, yeah, and in series to that one that triangular wave generating voltage source. Correct.
Okay, okay,
So here in the point two, that triangular wave generating voltage source vary VS2 and determine the range of VS2 peak for which the output voltage is within the speed limit, the specified limits, that is 3.6 plus or minus 0. Acha, can you try with this thing? The same thing. If you change the voltage source, take two voltage source separately, see what
okay.
it is coming. Okay, in the
Yeah,
LT spice. Okay, because practically it can come that change that you are getting, for 5K to 6K it can come for 5 from starting from 5K to 9K, I think 9 or 10K, that variation 0.3, it can come, no problem. But in LT space it should not come. So can you try with this it's taking two voltage source in series and check how the how you are
um,
getting the output.
do you
Okay.
want me to try right now or shall I try it offline?
Yeah, yeah, you can try it offline,
Okay,
and maybe no problem. You can try it. of because here in the point 2 that you have given, vary Vs2 and determine the range of Vs2 peak, that is the peak voltage of the here it is given 0.5, right?
Yeah, means
Triangular wave with a
0.5.
peak voltage of 0.5 volt. You can
Yeah,
try it one here also once, maybe by that time you can how much time will it take? 5
yeah,
minutes.
sure. Yeah.
Yeah.
So you want me to add one more voltage source?
Voltage source that will give maybe one voltage source for only giving the DC 4.3 volts, and another only 0.5 uh, that triangular wave, correct?
Yeah.
Peak
So
voltage.
triangular, I already have that.
That you can change.
I'll, yeah, I'll add this.
We are just trying. I don't know.
Some symbol gets hidden. Mhm.
Yeah, by the time God of finishes, anybody else has any doubt? Is there anybody who has any other doubts?
So now this triangular waveform should vary between
Initial
0.5 to 5. Is
this
it?
make sure that your uh, peak voltage is 0.5.
Peak is 0.5 and the lowest one is minus 0.5, right?
Yeah.
I need to add resistance.
So you have to show the theoretical calculation also, not only doing the experiment in LTspice. Why is it so? That you understood. You have to go through the theory of the experiment and know the theory behind it. Why is it taking breakdown voltage is this, and how much should be how much the source voltage should be there to have a breakdown constant voltage. So this thing you need to uh, go through the theory about this experiment. Then only
So
you will have.
that's where my confusion was. I was trying to correlate the observation with my
Yeah,
understanding of how it should work, but I could not, means like it was never touching 3.6.
yeah.
So,
But have you gone through the theory part, the theory of the this thing of this experiment? Why is it like that? How to calculate? Like
yeah, so
we
I
said
was,
those things.
I
Those things you
thought
have to
of
go through.
asking you, like, related to that, I thought of asking you how to determine value of RS if we know V in and we have a Zener of 3.6 and a load value is known. So, yeah, I tried finding out this, means reading into the theory as well.
Yeah,
Uh,
you will have YouTube tutorials also, so you can go through that. So that's what I said. You can change RS value and
do you want
change.
me to run this now?
Yeah, you can run it. See how is it come.
So this
One
is
case is showing like that, same before one, I think. If you increase the R value, RL value,
value of value of
RL,
RL. Yeah,
yeah.
so then it won't be the point 10 that we are trying out. It will be the previous ones that we'll be doing. We'll be varying the load instead of varying peak to peak, right?
You are doing the which one? You are doing only
Yeah. So
point 10?
this point 10 asks us to vary peak to peak to determine the range where the output voltage is within plus minus point 0.2 of 3.
3.6, yes. 4.3, it will be constant. You have to vary the peak to peak. Acha, you are talking about point number 10, right?
Yeah.
So this one, you need to change the peak to peak values and check that which for which ranges it will come properly. Okay. So basically, I wanted you to see that this should be the actual circuit that what you have produced now. Okay. Schematic.
This is just for point 10. For previous points, it was having a potentiometer and
Yeah. So now you just have given
a
one,
fixed value of 1K.
yeah. If you put maybe 500 RS, you have put 500.
Yeah, yeah. RS is 500.
So check.
Yeah, 1 second. I'll show that to you. Yeah, this is RS.
RS is 500.
But this one is
What is the period have you decided? What is the period of the pulse?
there are 5 cycles, and the entire 5 cycles period range lasts till point 1
When
second. 100 millisecond is the total
100,
duration.
that means 20 milliseconds is one period.
Yeah.
20 milliseconds is
1 by 20, 50
0
hertz.
point 0
50
point
hertz.
0
Point zero 0.02 millis. Point zero 0.02
2
seconds.
seconds, correct?
Yeah.
And 0.1. If you do 0.1, you just
Should I change the period?
no, I don't think that will make a change. Yeah, this thing is there. So that means what that. So 1000 divided by 1500.
2 by 3.
0.86, correct?
Mm,
2.86, the voltage is coming in. Yes.
okay. 2 by 3 of 4.3, right?
Hmm.
Yeah.
It should not turn on. The constant voltage it will not come. I think.
Yeah. So
Now, if you increase the that at
1.6.
some yeah 2.8667.
So this one is like, first of all, it is not 3.6 plus minus
Yeah,
volt,
yeah, yeah. It is
but that
way
that
more.
is 2.8, then plus minus something.
Yes,
And then
it should not go in like that.
so if I, let's say, decrease this peak to peak to 0 and
Yeah.
take it with a DC voltage, flat
Hmm.
DC voltage, the
Okay.
output will be flat at 2.8.
Yeah, check that. How does it come?
I find this one even harder to replicate on the breadboard, actually. So this is the output around 2.8 volts, and
Yeah,
so
I think it is. Sorry, I think it will be constant because that is what we are getting, right?
yeah, yeah.
2.866, correct?
So it should go above 3.6 so that it limits it to 3.6. Zener.
Yeah, yeah, yeah.
So what if I,
3.6, no, around 3.6. Like particularly, will not get 3.6. Maybe now if you try with 10K, let's say, instead of 1K R1 change it to 10K. How much is it coming? Yeah, change this to 10K. 3.4, 10K.
so shall I add now peak to peak to this one?
How you can add, you are getting 3.42, right?
Yeah, it should show us some tapering on the top. Will
Come like that. Should show 3.6. See, now it is 4.09 if I give 4.3, but then also it is showing 3.6, correct?
Yeah, so now if I add a pulse, it should show me some tapering on the top, right? It should not go beyond 3.5.
Check what logically it should be the same constant. So how much changes is there?
From 3.25 till 3.5.
So before it was 3.4, right? Okay, if you remember 3.4. Now it is 0.2 changes are there almost.
Yeah,
No? Less than 0.2
0.25
changes are
to,
there.
yeah, almost zero point 0.3 volt of change. Point,
Point 2, no?
point 2.
Less than point 2.
Yeah,
I think that is the thing. We will get constant voltage, but there is this because of that
but
triangular
this
wave. This
but
thing.
this one appears because we are using a load resistance of 10K.
Yeah, yeah. That is what you will see the like if you change the RL, the VTH is increasing, correct? Across the, so that's when you will get a constant, that constant, almost constant, 3.6 plus or minus, or 3.4 plus or minus 0.2 volt. Okay,
Okay.
that is the way of getting almost a constant voltage,
But I
of
believe
voltage
the
regulation.
objective of point 10 is to find out effect of variation
Effect
in
of
the line of
VS, yes, a variation of you
input
need to see
voltage.
the effect of the input voltage variation in the that triangular wave, how the peak to peak peak to peak voltage of the triangular wave change the
Output waveform.
output. Yeah, waveform. That is what.
But right now it is fixed. So every time I'll have to make a change in peak to peak and then take another graph, is it?
No, 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 no. See, for point number 10, you are saying, right?
Yes.
Determine the range of within which the specified 3.6 this determine the range of
So right now my peak to peak is varying between 0.5 minus and plus 0.5,
0.5.
right? So if I change it to plus and minus zero point 0.4, that's how I'm interpreting it.
Yeah, means you have to check the determine the range of VS2 for which the output voltage is within the specified limits, that is 3.6 plus or minus 0.2,
The
right?
first thing is that 3.6 doesn't appear as you have just,
That is the thing, because if I give 500 ohms and 1 kilo ohm,
yeah, it remains at
it remains
2.8.
2.8 variation is get at 2.8, and then there the zero point 0.2 or 0.2 or this thing variation is there. So you need to check whether this thing that variation is the in the peak voltage of the VS2, whether that is creating more variation in the output also.
Yeah, so that's the objective of point 10,
Yeah,
right?
yes, yes, yes.
I need to keep RL fixed. So with that,
RL and RS fixed,
yeah,
and only and VS1 also will be 4.3. Only you
yeah,
will change the peak voltage
peak to peak.
of the VS2.
But
Okay.
with RL 1K, I'll see the output varying quite a bit as well because
See
it doesn't
VS2.
touch.
See for VS2, if you increase VS2 peak to peak voltage, you
Mm,
will VTH also will increase. I guess so. No?
yes, but
So for
like,
that, you need to check at what voltage. So it will come in the specified limits of 3.6 plus or minus 0.2. If you increase the VS peak to peak voltage,
tell me what value should I be?
maybe more.
Point
Uh,
one or one.
1 and minus 1. Yes, check how your variation is there.
This one will be harder to replicate on the breadboard because the 5 volt of current on the on a single channel we can't get more than 5 volt
Okay,
from
okay.
ADLM kit.
How is it coming? See, it has now, before it was 2.8, right? Now it has increased, right?
Yeah, yeah,
So
has
it has now
but
the
it is means we also need to take into account that the RL value is 10K. If
oh,
I
okay.
pivot it back
It's
to
give it back to 1K. That I didn't check. Again 2.8. Showing a lot of variation.
because much of it remains below the Zener uh,
Yeah, yeah.
breakdown voltage.
I'll just maybe I'll confirm with professor and get back to you about this thing. Okay.
Okay.
Yeah. But anyway, your circuit looks fine.
But for this one in particular, for point
What
10, I need to change the peak to peak every time and take a separate graph.
and take a separate graph and check for which voltage it is. Actually, it is given for which the output voltage is within the specified limits of
Point 2,
3.6
3.6
plus or
plus
minus
minus.
2. Here you are not getting only
Yeah,
3.6.
yeah.
So that is one thing I will confirm with sir. And then uh, just update you. Is it fine? To
And
Victoria.
yeah, yeah, we will look forward to your response on this one.
Yeah.
And this
Anything
one,
else?
I look means it looks to me that this one will be a bit harder to replicate on the breadboard. Um,
Yeah, see, but in part two, it is written very RL within the available range and record the relevant waveforms if the available potentiometer is, that is record all the relevant waveforms and observations. I think that is required. No? This one, I think they didn't ask for it. They didn't ask for it.
So we need
Set up
not
the
do
voltage.
the
See,
point 10 on.
no, I guess so because here only see very only RL it is given.
Okay.
So very RL and within the available range and because RL you will vary with the potentiometer. You
Yeah.
have a 1K potentiometer, I guess, no? 10K
Yeah.
potentiometer is also there.
10, we have 10K potentiometer.
Oh, great. Then 10K potentiometer you use. And then see the available potentiometer range for which this it stays in the 3.6 value plus or minus.
I have a 10K potentiometer. I'm using it from some other circuit. So the one that we received in our
Hmm.
kits, in along with the components, I think that is still 1K.
That will I'll confirm with
Yeah.
Victoria and
So if
just
other participants in the call, they can
hmm.
confirm.
Yes, ma'am. It's
Yes,
1K only.
Yeah.
it's 1K only.
Yeah.
So with 1K, the
1K it will be
variations are,
difficult. Huh?
yeah, the it's it wasn't showing any variation. That's why I tried using 10K per pot.
Yeah, yeah, that's true.
And also for 10K, I've just shared the observations with you. Like after 6K, the output is
Hmm,
all
hmm, 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 hmm.
3.3 to 3.7.
Correct. So after 6K it is showing fine. So I'll confirm these 2 points. One is the point number 10 of part 1 and about the RL value. Correct?
Yeah.
Yeah. Anything else you have in doubt?
Yeah. One last doubt is it means in one of the points, it is asked to make use of two Zener diodes.
Where?
In the simulation only. Yeah. Point number 8, repeat 6 to 7 after connecting two identical Zener diodes in series.
Yeah. Then you just need to check the you connect two Zener diodes and see what you get out of it.
Yeah.
And output.
So how means do we need to connect them like cathode and cathode like facing each other or in the same direction? Like
That you
how
check it out.
like I did it,
Like that, cathode and not like that. How did you
I
connect?
can show that to you. So these are facing opposite to each other.
Hmm.
Is this the way we are
So
supposed to
you
do?
from simulation you will get an idea, no? How
Yeah, I tried.
both.
Um,
You can try
yeah,
both.
I tried it both ways, but
Uh,
like since if I join them in the same polarity facing upward, then the Zener breakdown voltage reaches 7.2, and there is no regulation with the uh, kind of input that I'm providing because the input
okay.
voltage always remains below 7.2.
7.2. Correct. Yes. 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 Because I'm already we are giving 4.3,
Yeah,
so it will be
4.3.
always down.
Yeah.
Yeah.
So
And what did you get after connecting this configuration? In this configuration, no, no, I'm not trying telling you to run it. So you have this configuration that you have used, and another configuration, the opposite one also you have used. Too.
yeah.
So what all inferences you get, you have to say it in the video.
Okay.
Right? As
So
when you have told no, you have connected to Zener series
with
like
same polarities.
same polarities, and then you have got 7.9. Now, if you connect opposite way, how is it coming? That also you need to find it out.
So we need to show it in both the configuration, like same polarity as well as opposing polarity.
Yeah, you can show. That is fine.
Okay.
That is part of the experiment. You can check how what means we wanted to see that what you infer from that. Okay, by doing
Okay.
the experiment. Okay.
Yeah. So my inference means I was trying to relate uh, theory with this observation. So one of the means if this is in this kind of configuration, like one is facing the means they are opposing
Yeah.
in opposing polarity, then one will be forward bias, one while the other one will be in the Zener breakdown region. So it will be like 3.6 is the Zener breakdown, but then
Mm-hmm.
zero point 0.7 for the other one to switch on in the
Mm-hmm.
forwards region.
Mm-hmm. Mm-hmm.
That will get subtracted. So the
Yeah.
Zener
So
breakdown voltage
those
will
things,
come.
yeah, those things you need to tell in the video. What are your observations? Why it is coming like that? Okay.
Okay. We'll try. Yeah. Thank you. That's
And
all.
anybody else has any?
With the previous experiment, I have some remarks. Means these were again have already been shared with you um, in our previous doubt clearing session for week 6 1, the FAT one especially, MOSFET one. Hello, am I audible?
Yes. So the previous experiment we have already had total of four
Yeah,
tutorial session, right?
yeah, yeah. So this
So
is again, yeah,
this
uh,
is if you have any doubt, you can convey us through your email or message. We will get
um,
back to you.
it's not a doubt which I'm seeking some clarification on, but just the observation that with FET, the
Hmm.
observations are very hard to make, and they keep means the values keep varying very often. Means the one round and the second round they don't remain the same, and the FET that is there with us, the MOSFET.
Ah,
I think it's a kind of a power MOSFET, and with
mhm.
3 or 4 rounds, it gets heated up quite a lot.
It's that picking up thing. That picking up thing, I'm not aware of because I have not worked with that. Okay.
So that's my observation that I would like to share with week 6. DJT
Okay.
ones were still like
Mm.
um, we were trying to emulate what is the objective was for the experiment, but with MOSFETs, uh,
There's heating issues there.
not just that, but with each iteration, at
Huh.
least I can tell you my observation, the graph don't remain the same. The observation is changed. So I cannot repeat my observations. If you tell me to repeat means do it
No,
again.
no. See, our idea is to check the LED driving circuit. Okay.
So
The transfer
yeah,
characteristics and the LED driver circuit.
voltage driver, yeah, voltage
That
divider.
is one thing. That is our objective. Okay.
Yeah, yeah.
So repeatability maybe because practically doing so many things are working. Okay. So I cannot particularly say.
So when we are trying to, let's say, find out the output characteristics of MOSFET, first, um, every run gives me a different observation and the graph changes. So it's not
It should
like,
not change, but for particular IV value it should not change. But I have not worked with that one, so I cannot give you any input on this thing. Okay.
okay, okay,
Yeah.
fine. Yeah. Anyhow, we already had quite
Yeah. Already you have submitted
many,
your
yeah,
experiment.
and we did have chance to clarify our doubts. So I don't have questions per se which I can seek clarification on. It was just an observation that
So
I thought of sharing. Yeah.
yeah, we'll move back to Abhilash. I think Abhilash has some doubts. 3.6 is not available. think Gaurav has done something. It has already been recorded. You can go through the video how he has changed. But if at all, if it is not possible, you can go with the nearest available. I think it is 4.7 nearest available breakdown voltage in a diode. Okay. Am I audible, Abhilash? Akhilesh, sorry, Akhilesh. Okay, fine. Anyone has any more doubt? So shall we wrap up? Victoria? Any more clarification doubts you have? Victoria, are you there?
Sorry, come again.
Yeah, so I think no, everybody has completed their doubt sessions.
Okay.
So
So
shall we
can
wrap
we
up?
wind up the mic
Yeah,
meeting
yeah,
now?
yeah,
Yeah,
I
sure.
think so.
Yeah, sure. Yeah. Thank you,
Thank you,
Dabashita.
thank you.
Yeah.
Thank you.
Yeah, if you have any doubts, you can contact Victoria. He will convey. She will convey your doubts to us.
Submission deadline for this would be this
I
and
think it is 15.
May 15th.
okay for both 7 and 8.
Yes.
Okay. Thank you, ma'am.